Assume that matrix A is row equivalent to B. Without calculations, we need to list rank A and dimension of null A. Then find basis for column A, row A, and null A. So A and B are row equivalent. If we look at closely, B is in row echelon form, where we have pivot here, and pivot here. A and B are row equivalent, means when we row reduce A into row echelon form, so we might get this, or equivalent to this. Okay, so first we need to find rank A. Rank A is number of pivot columns in this row echelon forms, because this is row echelon form. Here we got 1, 2, 3 pivot columns, so rank A is 3. Then dimension of null A, sometimes called nullity. Null A is 2 columns without pivots. Okay, there are 2 columns without pivots, so that's the dimension of null A. Now next we need to find basis for column A. Let's find the basis for column A. So A basis, in fact, is just collection of vectors. Look at here, we got 3 columns with pivots. So first column, third column, and fifth column. So we need to go back and refer to this original matrix to find a basis for column A. So a basis for column A is given by first column vector and third and fifth, because we have pivots there. So 1, -2, -3, 3, 4, -6, -6, 4, 9, -10, -3, 0. Okay. Next we need to find basis for row A. A basis for row A is, now what we have to do is, so we are trying to find basis for row A. We need to row reduce into echelon form, which is here. Okay, this is echelon form. Now we need to find the non-zero rows. So this is non-zero, this is non-zero, and this is non-zero. These are all 0. We don't go back to A. In fact, for a basis for column A, we go back to the columns, pivot columns here. But for a basis for row A, we just write these non-zero rows. So I can say this vector, okay, this vector is V1, this vector, okay, this vector, the second column V2, and third column is V3. If I list here, that they form a basis for row A. So V1, V2, V3. I'm just being lazy to copy these vectors, okay? And we need to find basis for null A. So to find a basis for null A, we need to solve AX equals 0. So we're going to find the vectors that are mapped to 0 vector. So AX equals 0. To solve AX equals 0, we always row reduce, which is B in this case. Okay, this is not unique, but we have one form here. So that is, which is same as R Bx equals 0. And when we solve Bx equals 0, we can say 0 here. We can write that x is, okay, first column x1, x2, x3, x4, x5, and here is a pivot. That means x2 is free variable, and so is x4. Okay, to solve this implies from the last there is no contribution. From second last row, this is 5. Okay, so x5 is 0. Divide by 5, so we get x5 0. Okay, this is done. From second row we get 2x3 minus 3x4 plus 8x5 equals 0. Oh, x5 is 0 in the previous, so this is 0. x4 is free, so x3 is, move this over, 3x4 divided by 2. Then from this is done. Now from the first row we get 1x1 minus 3x2 0, so 5x4 minus 7x5 equals 0. So x5 is 0, so this is going to be 0. X2 is free, x4 is also free, so this implies x1 is, just add and subtract, so we get 3x2 minus 5x4. So we got all components x1 through x4. Thus, okay, null A is in fact span of x, where this is x1, x2, x3, x4, x5, by the way. Okay, so, and this vector, when we write vector, they become, these vectors become bases. So that is in fact, what is x1? That's the 3x2 minus 5x4. x2 is free. Okay, so then x3 is here, 3/2 x4, x4 is free, x5 is 0, where x1, x2, x3, x4 are arbitrary real numbers. So this is, if we find the span of this, then we get this null space. Now we can write this vector in terms of a sum of two vectors, because I can see there are two free variables, so we can have x2 outside, that means 3, 1, no x2, no x2, no, and I can factor x4 out, that leaves -5 in the first component, no x4, 3/2, 1, 0. Okay, in fact this x is in fact a linear combination of these two vectors, so they form a basis. So a basis for null A is just a collection of these two vectors, 3, 1, 0, 0, 0, -5, 0, 3/2, 1, 0. Okay, and we got two vectors in the in a basis, so the dimension is 2 that we found earlier.